Hello everyone. Good evening. I am your host Vidit Kumari. Welcome you in this last day of 4 days live workshop on Python development conducted by Tech Octanet Services Private Limited. I am very sorry for the delay, but now I would like to add Mr. Harsh Pranjal on the stage to start today's session.
Good evening, everyone. So let's start. Okay, guys. So today is the last day, and today we are going to discuss about class and objects, right? So we were starting new topic. One thing we have missed yesterday, that is zipping and unzipping the zipped data types. Okay. So over last day, I have just missed one thing, that while creating a list, let's for example take only two lists, right? See, and using a zip, see, I think we have discussed that this zip is only containing the memory location where this combination is present, right? This zip is only containing the memory location, the hexadecimal memory location only. Okay. So last time what I was doing, that I was just skipping these two lines and just trying to unzip that memory location. Okay. So there is one very crucial property of while using unzipping, that see, this is the syntax for unzipping. Zip keyword, use asterisk, and then use your zip variable, right? So there is one property about this zip variable, must be an iterable, right? And what I was doing, I was just using unzip for this memory location. That's why I am getting the an empty list. Okay, see, this is what I was doing while unzipping. Print, right? See, this is what this is how the values we will get from unzipping, right? Now if we will be printing directly the variable, we will be getting the hexadecimal values. So if you want to directly print the zipped variable, first of all convert that into a list. We have seen these list conversions. Okay, now see, this is our zipped variable and this is the extraction, and of course the we when unzipping a zipped variable, we will get the extraction in a tuple form, right? Okay. If you want to convert that tuple, you have list conversion, convert A to list. See, now A is a list, B is a tuple. Okay. Now we don't waste much more time in this. Just go with. So just let me know how many of you are familiar with OOPS concepts, object oriented. Okay. The last thing is inheritance. Okay, guys. See, let's discuss one by one. Uh, See, guys, all these, the first two, encapsulation and abstraction, those are nothing but some theory part. Okay, these are the theory parts. You practically implement. We always practically implement encapsulation and abstraction, but that doesn't require any special keyword or something like that. Okay, polymorphism and inheritance are something that you have to take care while coding or implementing your ideas. But encapsulation and abstraction are somewhat theoretical type, right? See, we are again and again using this print, right? And we have discussed that this print is nothing but a method, a function. Okay, so see, press control, and when we go inside the code of this print, we are getting these many lines, right? See, these many lines. All these lines are meant for this print only. These many lines of code you will require if you want to print something. So what an abstraction is? Abstraction is nothing but, see, you are using this print again and again, but we are not aware about these implementation, right? This is what abstraction do. It hides the, what you call the, it hides the implementation. Okay, it hides the implementation and let you use the function only. That is abstraction. Okay, so for abstraction, hide the implementation from users. Okay, the best one of the best example is that if you are going to use the ATM, the ATM is showing you some messages or some functions like for withdrawal, for mini statement, like that, but you are not aware that how is the code written for those functions, right? How the ATM is working with the database, how the ATM is working with the bank, right? So that is what abstraction is. You are only allowed to interact with the meaningful functions. Okay, and the implementation is hidden somewhere else, right? That is what abstraction is. Okay, now encapsulation. See, so let's use some other function this time. Are you aware of the ceiling and floor values of a float? This basic maths only. The ceiling and floor values. Okay, guys, see. Okay, so suppose ceiling is a function. Okay, ceiling is a method defined inside this math library, right? Now take a look here. This is too much crowded. Use the basic print. See, see, this is nothing but a function, right? The definition of a function is written here, please. This is nothing but a function. Definition keyword, definition keyword. Open is the name of the function. These many arguments. Okay. So, what does encapsulation means? Encapsulation means binding each and everything, binding inside sorry, same name. So we have seen that while using a function, suppose this is a function, okay, suppose this is a function, right? Suppose this one is our function, okay. Now while we are working inside this function, each and every, suppose I have created some different types of mathematical equations inside this function and different types of variable inside that function. So each and every those type of each and every type of those variables are exist only inside this function only, okay. So that is the meaning of encapsulation. Each and everything is present inside the same name. For example, suppose if I create a function with the name, let's say some square root, something like this, right? And sorry, create a variable a, create a variable b, and then create a math sqrt a plus b. Now this variable a, this variable b, and this equation, all of them are defined inside a same name, inside the same name, that is some square root, right? That is what encapsulation is. Each and everything is defined inside the same name, okay. Now polymorphism, okay, if there are any difficulties in understanding the encapsulation, we will see that again while using classes. Now see, we can use print without passing any string. We can also use the print by passing a string. We can again use the string just passing the variable name, right? So we are using the same function again and again by passing different types of arguments, right? This is what polymorphism means. See, this print, this print method, this print function exists there, somewhere existing, right? So this print method exists there, which is handling empty arguments, a string argument, and a variable argument, right? So that is what polymorphism means. Existence of same, it is not only true for a function, okay, it is also true for a class and everything like that. So existence of same use message in more than one form. Guys, these are not to the point definition, okay, these are only for your understanding, right? So this is what polymorphism means: existence of a method where you can use multiple types of arguments. See, these arguments are totally like different from each other. We are passing a blank, passing a string, passing a variable. Now if you are passing some other variable, so this is not considered, these two statements are not considered as a polymorphism, because we are again passing a variable and then again a variable, right? But passing different types of arguments, that is what polymorphism means. Print exists there with different definition for a empty argument, different definition for the string argument, different definition for the variable argument. I think we have seen an example where we have used default, right? Oh, anybody who's able to solve this one? Okay, sir. Okay. Anyone who's able to solve this? Try this one. Okay. See, try to understand first polymorphism. What is polymorphism, right? So this function calculates sum of square roots, right? calculate sum of square roots. If I will pass 12, 13 and 14, this is a valid call for this function. Okay. Then again, if I will pass only 12 and 13, then again, this is a valid call for this function, right? Then again, if I only pass 12, all these three are a valid call for this function, right? The function calculates sum of square roots. All these three are valid calls. But see, first is taking three arguments, second is taking two arguments, and the last one is taking one argument. Now, how the interpreter work with these different types of calls? Okay, so see, this is our function, calculate sum of square roots. Now, suppose this is our first call. Okay, this is our first call where we are using three arguments. Suppose we are using three arguments inside this, right? So for this function call, for this particular function call, there is a function, right? There is a function for this call. There is a function. Okay, this call is calling a function, right? Then again, we have a function call, but this time we have only two arguments. Now for this function to execute, there exists some other function of same name, right? Uh, these two functions are of same name. They are exactly same. They are not some different entities. But consider it like there exists a copy of function, the copy of a function which is accepting only two arguments. This is accepting only two arguments. Again, we have a function call where we are passing only one argument. Okay. Now consider there is another one copy of the same function, another copy, but same function. The names are not different. It is the same function, but the copy exists, right? So for this function call is calling this function. Now just observe very carefully. When we are passing three arguments, it is calling a function. Suppose function 1. When we are passing two arguments, it is calling a function 2. If you are passing only one argument, it is calling function 3, right? Those three functions are accepting different numbers of arguments, but those three functions have the same name, that is calculate some square root, right? Suppose for this one, we are calling function 1 and the name of the function 1 is calculate sum of square roots. Again for this one, we are calling function 2 and the name will be the same. Again for this one, we are calculating function 3 and the name is same. This is what polymorphism is. Okay, Saurav, so what basically you are not able to understand any particular topic? Guys, how many of you are able to understand what polymorphism is? Okay. So after polymorphism, we have inheritance. Just leave the inheritance for now. Okay. Okay, polymorphism. Okay. So I'm repeating polymorphism for the last time. See. So simple, just remember one thing. The basic meaning of polymorphism is the existence of something with different. Let's see, take an example. Okay, this is a very classical example of polymorphism. Suppose there is a person, right? So this person is a father to someone. Okay, this person is a, suppose, brother of someone. Again, this person is a worker for some company. Again, this person is the husband of someone, right? So are there are different persons? No, only this person exists, but it exists in different states. Brother for someone, father for someone, worker for someone, like that. See, the same person, the same entity exists with different identities, right? That is what polymorphism is. Okay, so suppose for the father side there is one copy, for the husband side there is one copy, for the worker side there is one copy, something like that. Okay, these copies are not different persons. Yeah, that's the method of uploading. These copies are not different person, the same person, but in different states. Okay, that is polymorphism. Now we have seen what is encapsulation, abstraction, and polymorphism. Leave the inheritance for now. So to implement these polymorphism and these OOPS techniques, we need a medium, right? And that is nothing but class and objects. Okay, we have class and objects. Now what is class and objects? So by default we are the same but different parameters. See, by default we are using classes again and again, but right now we are going to understand it from the basic beginning. See what a class is. We know what is an integer. Integer is a data type, right? Suppose this is nothing but a memory block in the RAM, which is storing an integer. Okay, suppose this is a memory block which is storing the integer. Suppose it is storing 100, right? An integer memory block can store only one value at a time, not more than one. If you are going to store 20, then this 100 will be deleted and 20 will be there. Okay, so okay guys, let's first see the class and objects, then we will again visit polymorphism. See, so suppose this is the memory block of an integer variable inside your RAM. Now, who told the RAM that how does the memory block will look if you are creating an integer? No one but the interpreter, right? The interpreter says the RAM that this type of block I need. The block must contain an integer type. The integer can contain the memory like from suppose 8 bits. Okay, so the interpreter defines to the RAM that this type of block I need. Okay, for a list there is a block and there are several blocks. Okay, and the address of each block is stored inside this block, right? This is how list work. Okay, now who told the RAM that how does this memory location will form? Okay, the interpreter explains to the RAM that these types of memory location is required. So the RAM form these memory locations and give it back to the interpreter. Okay, right? This is how somewhat the operating system works. Okay, so now suppose you want a memory block of your own. You want to define the memory block by yourself only. You want a memory block, and inside that memory block you want different types of memory block inside that one. See, inside this integer there is nothing but 100 is stored, right? But I want to create a bigger memory block inside of which I want to store whatever I need, whatever type of variables, whatever type of memory blocks I want to store. I want to create that memory block. Okay, so now the interpreter is not able to define to the RAM that what type of memory block is required. So it cannot be formed. Okay, right? Why? So how the memory block for an integer and how the memory block for a list will be defined, that is already written inside the interpreter, the Python code, right? See, let me show you. See, inside this list, each and everything is written there, that how the memory block will look, how it will perform. The add, there are, see, the insert method we have used, the append method we have used, the copy method we have used, everything is defined there, right? So to create a memory block of your own, you have to define how the memory block should create, how the memory, what type of functions will be for perform on that memory. See here, for list, let's check the zip. No, list. It is more familiar one. So see, inside C, it is a list. Okay. Now inside that list, someone has defined what the copy will do. Someone has defined what the append will do. Someone has defined what the extend will do. Right. There are things. These are dunder methods. Right. So how the sort will perform on the list. All these things are there. Okay. So if you want a custom memory block for yourself, you have to define all these things, right? So for list, those count method, append method, those are required, right? But suppose I told you that we need a memory location to save details of a student. So inside that memory block, what we will need? A name variable to store the name of the student, a grade variable to store the grade, a department variable, something like that, and suppose a university variable to store the university of that student, right? All these things are required. Now to create this particular memory block, you have to define some code inside the Python, right? The interpreter will carry this code and tell the RAM that these type of memory locations were required, and the RAM will form a memory location for you. Then whatever you want to perform on those values. Suppose you want to perform sum up all the marks that the student has got, check how many students belongs to the same university, something like that, or whatever operations you will require, right? So we have to create this code inside that Python. Okay, now I think everything is clear till now. Okay, now see, so we have seen that we are going to create a new memory location of our need, which can be defined by us. So you can say that this memory location is nothing but a user defined data type. Nothing but a user defined data type. And how that data type is defined? That is defined using classes, class and objects. The Python code which we are going to write, and the interpreter is going to create that. That's it. So this Python code is written inside class and objects, and this memory location is known as user defined data type, right? The proper definition of a class, right? Let's go to the proper definition of a class. So there is one theory why we need class and objects inside a programming language, right? So suppose you are a software developer and there is a need to develop the software for a bank, a very big bank. There is a need to define a people, sorry, a person. Suppose a person inside your code. And what does this person holds? Account number, right? Some balance. If there are some passwords or anything, right? Name. Okay, age, gender, something like this. You have to define a person inside your code, right? Right. So this is the very basic sense. If you are going to create some software for a bank, you have to create a person inside your code to store these datas for this person one, right? Then again, you have to define it again for some person two. Similarly, you have to again define it for some person 1000, right? You have to define it 1000 times. Okay. So there is one thing, just define a person name list. Okay. And give it a account number, give it a balance, give it a password. Suppose the password is 23 and ABC. Put it inside a string. Okay. Give it a name, give it a age, and give it a gender. This is what we will do. Now suppose you have to do this for 1000 times, right? You have to create 1000 persons. And again, if there is a new customer for the bank, that person number 1001, then what you are going to do? You are going to open your code again and then create a new person. So we are not going to do that, right? So the basic meaning of class and objects are that class and objects helps you to represent the real life entity inside your code. Real life entities. A person is a real life entity. A account is a real life entity. A dog is a real life entity. Something like that. Okay. So let's first see how we define a function and all that. So let's first see how the syntax works, how class and objects work. Then you'll get a better understanding for that. Suppose we define a class for a person. This is the syntax. Use class keyword. Always try to write your class name with capital letter, starting with capital letter. This is just what you say a convention. Okay, not necessary, but always try to use capital letters. And define whatever you need for that person. Suppose I need a name of type string. Okay. I need a age of type integer. I will just live with these things. Calling the same function with same argument means that it is polymorphism. Okay, we will jump to polymorphism. Just wait for that. So this is a class person, right? Now what is the difference between the class and the object, right? So okay, let's define class as the blueprint to create object, and object as the implementation of class. Now what we have seen here, this is the blueprint. This is telling the interpreter that what type of data structure you need, what type of memory you are going to need. So this is a class. It is a class, right? And remember one thing, when you are using an integer, you are giving that integer a name, right? A is the name for this variable, right? B is the name for this variable, right? So this is the memory block created by the interpreter. Now you have to give a name for this memory block. Okay, so that name, that particular variable is known as object. So what A is an object of class integer. See, someone else I think raised the question that whenever we are printing the type of a variable, why it is written with class int. So A is nothing but a object of class integer type, right? A is the object of class integer type. Now class integer is already defined in Python, so the interpreter knows that how should the memory block will look like. But person is not defined inside Python, right? We have to define person. So person is the blueprint how the memory block will look like, and we have to create the variable for that person, right? Suppose we create a person one. This is how we create a person one. Okay, you guys, we will see about that. We cannot use input. See, we have seen that whenever you want to create a empty list, we use this, right? List is nothing but a class. See, list is nothing but a class. Leave this, what is written inside this, just leave this one. Okay, list is nothing but a class, and different methods are defined inside this class, right? Okay, after list we have dictionary as a class, and different methods are written inside this dictionary. After that we have we didn't discuss about set. So okay, so this is how we will create a person one. Now the interpreter, now there is a memory named as person one exist in the RAM, right? Now what type of variable can you access using person one? We have created two variable, that is name and age. Now how to access those variables? Just use the variable name for the class, then use whatever type of variables you have to use with dot operator name. Now let's see. See, we will get hers, right? Now if I will print, what we will get? Nothing, zero, because we are not assigning any value to age, right? We assign the value to age, use. See, now we will get 22. Okay, this is how person one will be created and used. Okay, so just see syntax to create a class. The class keyword, class name, small brackets, colon, and your attributes. Now there are some terms we are going to use again and again. That is, these variables inside a class are known as attributes. Okay, attributes. If you define a method, a function inside a class, a function inside a class, that function is known as method. Outside the class, what type of functions we have seen yesterday, those are known as function. But you define a function inside a class, then that is known as method. Okay, that, see, this list one dot copy, this copy is not a function, it is a method, it is known as a method. Okay, now these two things create a class, means these two things are present inside a class. Okay, attributes and methods. Variable inside the class are known as attributes, and function inside a class are known as methods, right? Now guys, just let me know any problem, any questions till now, any doubts. Okay. Now see, now we are at this position that we have created a class, a memory block is assigned to us, right? There are some attributes which is holding the name, age, and suppose the salary of a person. Okay, now we are again, okay, I have deleted that question. We are again stuck to the same problem that what happens if you have to create 1,000 persons, right? So those 1,000 persons are not going to have the same name, okay, same name or same age or same salary, right? For each and every person, person 1, person 2, person 3, you have to define different classes, right? So here comes the theory about the global variables and the object attributes, class attributes and object attributes. Okay, suppose, let's take this one. Suppose you are creating a class name as student, which is storing the student data only, right? So whatever number of student you are going to create, you are going to create 1,000 students. All students are having the same university, right? All are studying in the same university. Okay. Now, but the name of each and every student will be different. Okay. So suppose if I have a student 1 and I have a student 2, right? Now student 1 dot name and now they provided the name for student 1, that is that this print statement is going to print hers, but we not define the name for the student 2, right? But see, student 1 will print hers and student, wait, let's assign it with a value of name 2. Okay. See, the name for student 1 is defined as hers, the name for student 2 is defined as name 2, and again I have printed the name for the student 1. Now this name and this name, both are two different things, both are two different attributes. Okay, let me show you. Just take a look. I will explain each and every line. Okay, just now, just observe. Suppose we have a name, temporary name, right? And if I will print just remove this line, remove that. Okay, so we have a temporary name, we have a name for student 1, we have a name for student 2. Okay, now see one thing, what we have seen, that class is used to create a memory. Okay, if this object 1 is using this memory, then it should have the memory, some memory location. Suppose that memory location will be 1. If this object is using this memory to store its name, that is name attribute we have seen right now, then it is again accessing the memory 1, memory location 1. If there is some object 3, that is again accessing that memory location 1. Okay, now let's print id of the name attribute assigned with student, the name attribute assigned with student 1, and the name attribute assigned with student 2. Okay, let's see. See, all the IDs are different. Okay, all the IDs are different. It means this object is accessing some other ID, sorry, some other memory location. This object is accessing some other memory location, and this object is accessing some other memory location. So what is happening right now? Okay, see, inside a class, you have a power to define two types of attribute. Okay, two types of attribute. Just take a note. Those two types are attributes binded with the class and attributes binded with the object. Suppose this is the name of the university, which is going to be common for each and every student. Okay, this is the university attribute common for each and every student. Okay, inside this class, we have told the RAM that this type of memory location is required, right? So if you are going to create an object, suppose this is object 1 and this is object 2, you can define the variables assigned to that particular object, that attributes, that personal attributes. Name is a personal attribute for object. A person 1 has name, some name, the person 2 has some other name. Okay, those are different attributes, right? Not like this university one. This university, the name of the university for each and every object is common, right? But name of each and every person are different, right? So for that, those type of variables are defined inside the object. Okay, these are the name variables defined inside the object. Okay, now just see one thing. If you are asking for the university, the common memory which is shared by all the object, the owner of that memory is the class. The owner of that shared memory is the class. See, the owner of this shared name is class. Okay. Now, if you want to access the personal memory, the personal data, the personal attribute, the owner is the object. Okay. The name, the value of this name variable, the owner for this name variable is this object 2. That's why we are getting different memory location for all these name attributes. The owner of this name attribute is this class. The owner of this name attribute is this object. The owner of this name attribute is this other object, right? So guys, anyone having any doubts till now? What is a object attribute, a class attribute? And let's see some more examples. So let's create student 1 and I want the blueprint from student class, right? Now just let me know which, sorry, not a bracket. Okay, which type of attribute I am using, the class attribute or the object attribute? Guys, which type of attribute I'm using? The university is which type of attribute, the class or the object. Just take a guess. Yeah, that one is class attribute. Okay, why? Because I'm accessing this using the class name, right? I'm accessing this variable, this attribute using the class name. See, to access whatever type of attribute you need, use the object name, then dot operator and the attribute name for object attributes. Okay, for class type attributes, use class name, dot operator, attribute name, right? Now, see, there is no name attribute is defined here. No age attribute is defined here. When you are just writing it like this, dot name, it means you are creating. See, here is what a equal to 10. I've just created an integer named as a and assigned it a value 10, right? It is somewhat similar to just creating a name variable which is holding the value of the string, right? This statement, this line and this line, it's somewhat similar. Okay, I have just created a name attribute inside the object. The owner of this name is this object only. Okay, this object one is the owner of this name, right? See, now type of st1 and you will get class student. Just forget about this main for right now. Okay, just leave this one, class student. Okay, let's see what we will get if you will try to get the name. See, name is nothing but just a variable. It is of type string only. It is what is name? Name is just an attribute. Okay. See, if I want to print the type of university, then again, hmm, see, then again it is of type string. This university and this name are nothing more than but just a variable, just an attribute. Okay, this university is attribute for this student. This name is attribute for this object only. Okay. Okay, guys, just let me know any doubts. Just name it as class attribute and name it as object attribute. Okay, so no doubts. See, okay. So we have a class, suppose named as person. Okay, we have, see, this is how we define a method for a class, a function inside a class. Okay, a function inside a class. Same def keyword, your function name. Suppose I want to give the function name as my sum. Then if you want to pass, you have to pass some attributes. Now, just note this one. It is mandatory to pass at least one attribute to a method of a class, right? One attribute. And by convention, we name that attribute as self. Okay. Now, why? We will see it. See, if I will person one is equal to person, right? Now I have defined a name attribute, object attribute for that person, right? Now, see, to access whatever you need inside a class, just use the object. Okay, to access whatever inside the class, use the object dot operator and the method name. No need to pass anything. Okay, for self, for the first attribute, no need to pass anything. Then again, we will get an error, right? And the error is name is not defined. See, name is not defined, but we have defined name for that person, right? So this is this type of condition where we have a class, we have an object, right? We have an attribute inside that object, that is name, and we have a method. Let's define it. We have a method inside this class. Okay, guys, just quickly let me know, this method is bounded to the object or bounded to the class? The method we have defined, that my sum, is bounded to the object or to the class? Okay, so that function, that method is written inside a class, right? So that method belongs to the class. The owner of that method is the class, right? Suppose if I have defined a name, an attribute, okay, and if I want to print, I can just use the class name. Okay. See, now what we will get? We will get my university, right? Why? The person, the class is containing an attribute with some values, okay? And again, inside that function, that method, we are trying to print that, right? Similarly, if you want to print this name, okay, inside the method in a class, okay, see, there is one attribute, that is self, sorry, one argument, that is self, and we are not passing anything. So this is by default, this method, sorry, this object person1 is sent to this self attribute. Okay, this self attribute is containing this person1, right? And to access any object variable, any object attribute, you have to first write the name of the object, then dot operator, then the attribute name, that is name. If now you will print, sorry, see, we are getting the class attribute and then getting the object attribute. Okay, so this is how the method work inside a class. This is how you call the method. Okay, this is how you access class attribute. This is how you access object attribute. right? Now, suppose we have a class in this person, then again we have a function, my sum, we are getting self, right? And I'll just leave this one right now. Let's create two persons. Okay, person one is equal to person. First of all, create the variable, create the object, right? Then use the object. Person one dot amount, because we have 2000 amount, right? Again, person two equal to person two dot amount 3000, and both of them have to pay some tax. Okay, so now see, there there is this one object, there is this other object. Now when there is a need to define a class attribute, okay, so both objects are holding their amounts, right? But whatever amount of tax they have to pay, that should be common, right? That is common. So for this, they have to share this memory location from the this attribute from the class. They're sharing this attribute, right? If now suppose tax as a value of suppose 100, okay, and let's print. See what we will get, 100, right? See there we are not going to we have not defined any variable for variable name tax for this object person 2. Similarly, if I want to print person 1 dot tax, what it will print? Again it will print 100. But we didn't define any attribute named tax for this object 1, right? Person 1. Both of them are sharing the attribute of the class. So guys, take a note that the class attribute is common to all objects. Okay, class attribute is common to all objects. Class attribute common to all objects. Okay. We have a method, right? Now, okay, so the requirement of this method is we have to return the actual amount after subtracting tax, right? Guys, just suppose if I will call it using person one dot my sum, right? Sorry, we are calling this method. Okay, for function for person one, I have to return some values, right? I have to return the actual amount. Okay, let's save that return amount in some variable a. Okay, just let me know what line of code I will write here inside this brackets to return the actual amount after subtracting the tax. Just copy paste the code line in the chat. See, these all class and objects are a little bit confusing, but if you work with them again and again, it will be clear for you. Self dot amount is correct, but we also have to reduce the tax, right? Subtract the tax. from the amount. If I have to only print the amount, then why there is a need to call this function? I'm just going to use it here. Right. We have to subtract this tax, right? And we are so for close. So we have to subtract the amount with the tax from the amount. Just use self dot amount to access the amount from the object. Self dot amount to access this variable, this value, right? Okay, and then use person dot tax to access this variable, this class attribute. Okay, now only return this value. What we will get? We'll get 2000 minus 100. Okay, now see. I'm sorry, this is the right thing. Class attributes access using objects. Right, now for this one, just repeat person dot my sum and save it with b only. Print b. Now guys, just take a look. I think the picture is pretty clear right now. Why we need class and objects? Suppose this person is a new bank account in the bank, right? And you are going to create new accounts for them. So for creating the account, that function will be maybe of hundreds of lines, right? So this person one is using the same method. This person two is using the same method. If there is someone like some person, 1,000 person, right? We can also create that easily like this. Okay, and that person will again use the same method. No need to write the method again and again for different persons, right? So this is the use of class and objects. Always improve the reusability of the code, right? Now let's see. So guys, everything clear till now. We are going to see some very good topics about class and objects. If you are having any doubt, okay. So see, so, this is our class. This is our class. It is a blueprint. Interpreter is using that blueprint to create a memory location, right? So there is one special thing known as constructor. Constructor. So while using this blueprint to create the memory location, right? The constructor defines that defines the interpreter that how the memory location will be created. How the memory location will be created. For example, see, suppose we have a class student, right? And we have some attribute university, okay, of type string, and we have student one of student, right? Print st1 dot university. Okay, we are accessing this university only, right? What we will get? See, we will get a empty string, right? It is a empty, okay, instead of string, let's use list, right? To be clear, see, it is an empty list, nothing is there, right? Okay, suppose there is a need, there is a requirement to define that it should contain something. Okay, the university should contain something, right? So for that we use constructor, and constructor defines that how the memory should be constructed. Okay, see, the memory is created well, right? So then why there is a need of constructor, right? So uh, just take example. Let's clear this one. We have suppose a class account, and we have something known as balance, right? And it is of type int. Okay, and while there is first account is created, okay, and now we will print account one dot balance brackets. See, it will print 0, right? We get 0. Why? Because no value is defined for the balance. But if you are have visited any bank to open your account, you always experience that the bank requests you to deposit some initial amount, right? Suppose just consider the same scenario here. The person this account one is going to open, and they want some initial balance in their account, right? Some initial balance. So to achieve this type of things, see, we can use account one dot balance is equal to 100. Now it will print 100 only, right? Right. This balance and this balance are two different things, but we achieve our goal. It is printing 100, some initial amount, right? But this is a type of operation, right? We are creating a variable, creating attribute, and assigning the value. Instead of this, there is one more thing we can do. That is, we define a constructor, right? And the basic definition of a constructor is it constructs the memory for the class, for the object. It constructs the memory for the object. See, there are too much irregular, what we can say that, suppose we have a account and someone is defining a balance, right? There is some user which is defining a balance. If you are now, there is some user which is defining a name. Okay, now if you give the user to define the attributes, the variables for a object, suppose there is a scenario, you have created account 2, right? This account 1 is created by user 1, this account 2 is going to be created by user 2. It also creates an attribute name. Now it is going to create some other attribute, that is university. Okay, so there is no need for this university variable, and this university variable attribute doesn't exist for this account 1, means user 1, right? So if you are giving the power to define the variables for each user, so to define, if you give the power to define the attributes to the user, they are going to define anything, right? So the constructor can use to define memory construction for objects. Okay, now let's see first, let's see the use. Suppose we have a same class account, the bank name for all the user will be same, right? Use of type string. Now see, this is how a constructor is defined. This name, this predefined name, double underscore, then init, then again double underscore. This is a predefined function and you cannot change that. Okay. And again, it is a method, so it receives self, right? Now this self is nothing but an object, right? We have seen that this self is nothing but the object itself. Okay. So here, create whatever type of attributes you need. Create self.name and take the input. Someone is asking for the input, right? Take the input. Now take some balance. Take it a float. And then input. Okay. Instead of name and balance, what else do you need? You just leave these two. Okay. Now, for the first time, by yourself, just define the, instead of just empty string, just define the bank name here only. Okay. Now, suppose you create an account one, right? And now see, if I will print, account one dot name. Okay, let me use this. Just leave this input statement for right now. We'll see that one. Use some predefined name. Okay. See, when we execute this one, see, we are getting the name hers, right? For this account dot name. Now, see, if we are not defining any constructor, right? Now what we will get? We will get an error. This name is not defined. Account object has no attribute name, right? The object account one has no attribute name, and we are accessing the name. For this, you are giving the user the power to create variables for themselves, attributes for themselves, which is not easy to control. Okay, right? So while creating the constructor, what it will do? See, we are getting the name as, right? Now, how the constructors work? Guys, any doubts till now about the constructor? Why we need a constructor and anything else? Okay. See, we have a class, and suppose this is the constructor. Okay, written inside that class. When the memory block is defined for this class, okay, the memory is going to define for this class only. The memory is constructing for this class only, right? And we have a constructor there. What this constructor will do? There is an object. Okay, what this constructor will do? If there is a requirement, if you have created any class variable, there exists some class variable, right? Now what happened? The first statement, the first line. Okay, let me show you the debugging. See, when the interpreter is going to define a memory location for you, the constructor helps it to create if there are any object attributes related to objects. Okay, the new attributes related to objects were created. What we are doing, so previously what we are doing that we are creating the objects outside the class, right? This amount is created for person 1 and person 2. This name is created for person 1. So who is creating this name? No one but this object only, right? But here we have the constructor. The constructor helps to assign the memory for this object, so for this attributes, that is suppose account number and name. Okay, yeah, the name, the main memory occupied, this main memory which is occupying on the RAM. The name of the memory is the class itself, this class account. Okay, it is nothing but account. Okay, and this one, this object created here, this is again a memory block, nothing but a memory block, and that one is known as account 1. This is account 1, right? So okay, so just leave the memory management for right now. That is a little bit complicated. If you are not defining any class attribute, then there will be no memory assigned to the class, right? See, come back to the constructor. So the constructor helps to define the attributes inside the objects only, right? Let's see how the constructor works. See, for we have seen a method, right? Here. See, we have seen the method. You have to call the method by yourself, right? But in this case, we are not going to call the constructor. The execution of the constructor is by itself. Whenever you are creating a object, object is nothing but the variable of account, right? Whenever you are creating the object from account, the constructor will be called by itself, by the interpreter. Okay, there is no need for the explicit call for the constructor. Let's see how it works. This class thing, see, the first thing, account 1 account, right? The first object we are creating, right? When we are creating the first object, it jumps inside the constructor by itself. There is no constructor call here, right? We are not calling the constructor by ourselves, but it jumps, the code jumps inside the constructor. Okay, now after defining the name, it comes back to the print, come back to the same line, because its constructor is nothing else but just some special method. So method is called from line number 10. After execution, it will return to line number 10. After that, print statement, and it ends. Okay, now if you have noticed, the execution starts from line number 4, not from line number 10. There is something happening inside this line number 4, this line number 1, and then again it returns back to line number 10, right? Then again the execution starts from here. So what is happening? See, suppose if I will remove this, constructor, class, object creation. See, we have a class here, right? And for that class, that blueprint, you have to create a memory. And to creating a memory, we have defined a constructor. Okay, it is our constructor. Okay, so what happened when the interpreter goes for creating that class? First, the blueprint will be ready. Then only you can create the what we call that variable, that object, account 1, right? First, the blueprint should be ready, right? And the responsibility to create the blueprint is of the constructor, right? So first of all, see, before class itself, before executing the class itself, the code will come to the constructor only. right? So the code comes to the constructor. The constructor defines that there exists a class which with these blueprints. We need these memory location inside that type. So after coming to the constructor, this class is created. This class is created inside the memory. Okay. Now after that, the creation of this class is completed. The creation of the blueprint is completed. After that, this object account one will be created, right? We need the object account one. Okay. For that, the object will be created. For that object, again the constructor will be called. Why? Because after completion of the creation of this class, this blueprint, we are again creating an object. And for that object, this constructor will be called again. Okay. So constructor is called. There are some codes inside that constructor. Executed, execution completes, then the print statement, right? This is how the constructor works, code flow works. Okay. So as we have seen that in these cases, we are not defining any constructor, right? But again, the memory is allocated to person, the memory is allocated to person one, and name is defined. So if you are not defining any constructor, the interpreter from themselves provides you a default constructor. Okay. By anyhow, you have to create this class inside the memory, right? And the responsibility for creating the class is of the constructor. So if you are not defining any, the default constructor is provided to you by the interpreter. And if you have defined the constructor, then there is no. Now let's see. Just first. Okay, now let's see examples. Okay. See. Okay, instead of examples, I've told you that what happens when a customer comes with some initial amount to deposit in its bank account, right? Suppose we have an amount. We ask the customer to enter the amount. Right? So constructor is nothing but a method, right? Just transfer the amount here. This argument, pass the argument from here. Okay. The first argument inside any method inside the class should be the object, should be receiving the object. Okay. Instead of self, you can name it anything. Okay. Suppose my object, anything. But the first argument should be the object itself. Okay. Then amount, then keep the amount. This one, print name, and then print amount. Now suppose we have seen that how encapsulation works. Okay, encapsulation works for that square root of print statement. Suppose if you have completely encapsulated this class, this is written somewhere else, then what the user will see this type of control panel will be visible to the user. So user have no power to define new attributes for this one. Okay, new attributes for your object account one. It is asking for amount. If someone has come with the amount, suppose 200, then again it is asking for your name and wait. Oh, sorry. Instead of amount, it is balance. Asking you for some initial amount, a name, and your amount and balance will be displayed. So this is how you can say that software development works. Class and objects are very powerful things. Okay, so let's see. We have seen the constructor. Okay, there is one more thing. Till now we have seen this like 1,000 times again and again. See, inside this list class, there is a constructor. And I have told you that list were assigned a memory, some memory, suppose some memory capital M1. Who is assigning this memory? This memory is assigned by only this constructor, init constructor. Now there are multiple constructor. We'll see about that just right now. Okay. So uh, these memory managements or the assigning of the memory for the class will be done by the constructor, right? Guys, any doubt about constructor or anything till now? I think it is pretty clear what is a class attribute, object attribute, how to call a method. Okay, let's see. Now let's create some classes. Some, suppose you have create an account, okay, and we have bank name, bank, and we have to create a constructor, say double underscore init double underscore self. What is this? So it is a return type, right? See here, it is a method. We are returning something. So we have seen that it is not compulsory to define the type of a variable, but for documentation purpose, if you want to define the return type, that what type of data this function will return, so it will return an integer type, something like that. There is no significant meaning of this, right? It is only good for documentation. Now inside this, create name, right? Create balance will be given by amount. We'll take amount as argument. So the account number, let's take the input, right? And let's give this, suppose create a method of withdrawal. And what we will withdraw? First of all, the object, then the amount to withdraw. Now, first of all, let's check if the user have that much amount or not. So the balance variable is holding the current balance of that account, right? So check the balance is greater than or equal to amount. If it is, then print withdrawal completed, completed, and set the balance. We have to reduce the amount, right? Just included withdrawal completed of amount. Okay. Or in else condition, print balance and give them the balance. Print balance is, we have the balance inside self dot. Okay. After this withdrawal, you can provide many more methods. Suppose let's define one more, that is deposit. And for deposit, there is no need to check any type of that amount and anything. No if else will be required. And first of all, self dot balance is equal to amount and then deposit completed, right? And one more thing, that is balance inquiry. And we need only self for this one and print current balance, and that will be self dot balance, right? So this is what a typical class will look like. There's it should also contain many more methods, some authentication method and something like that. But this is a very basic one. Let's create some. I just copy paste it to. Okay, let's create account one. Okay, guys. Now I am getting an error. Okay, so anyone just let me know why I am getting this error. Why we are getting this error? Yeah, variable amount is not defined. It means that this constructor, this init, is trying to create a memory and it is asking for amount, but we are not transferring anything, right? There is no argument here. Okay, so first take the amount and ask them to provide account opening and right. Now let's see. Let's provide it a amount of let's first perform some operations, then one dot. First of all, let's deposit some amount. Deposit. First of, let's use balance inquiry, right? Balance inquiry doesn't require any arguments. Okay, then deposit. After deposit, then also, okay guys, yeah, there is one thing. If you want to suppose after deposit, I want that this balance inquiry method will be called. The user should the new balance should be displayed to the user. For that, this balance we have to call that balance. Okay, so just nothing, just the same thing. Self dot balance inquiry. There is nothing special. This is again the object. Here the object is named as self, and the object is calling this method. Okay, nothing new, right? Okay, we have deposited. Then let's create. Let's use withdraw, and let's withdraw some amount. Okay, this withdraw will be called again. Let's call the balance inquiry after withdraw. Okay, instead of writing here the balance call, right? And we have used withdraw, deposit, balance, each and every methods, right? Let's see how it works. So see, this is how the screen will look to the presented to the user, which is creating the new account, right? So if there are some initial amount that is 100. Oh, I just forgot to pass amount here, right? See, 100, enter your name, enter the account number, suppose 1234. There are some problems. Okay, guys, just let me know why I am getting this curly bracket self dot balance. Why I'm not getting the value of the self balance? It should represent the value of the self balance, right? What am I missing in this print statement? Okay, so it should be formatted with F formatting. Here I have, I just forgot to leave that. Okay, it's again amount will be 100. Again name, again account number. Now see, it's displaying the current balance. Again, asking for amount. Suppose let's give it 300. So deposit completed. My current balance is 400. Now let's try to withdraw 500 from it. See, low balance and current balance is 400 and the program terminated. So this is how you can use class and objects to create functions. Um, this one. So have, yeah, okay. Let me tell you one more thing. See, now let's talk about that encapsulation and what is their abstraction here. Okay, so see, each and everything inside this class comes under only one name, that is account. Okay, this is encapsulation, right? Now abstraction, we have seen the execution right now. Okay, we have seen this execution. So the user who is entering data here is not aware that how you have implemented the methods and how the class is formed and how the constructor is made, right? So that is abstraction, just providing the necessary features. Just providing the necessary features, that is the values to provide and the strings here, string formatting, something like that. Okay, and hiding the implementation, right? That is abstraction. Okay, polymorphism. Let me see if I have implemented polymorphism here. Okay, guys, just let me know if polymorphism is implemented here or not. Okay, so there is no polymorphism, but if suppose I will provide a default value to this amount, that is 0. Okay, suppose there is a user who is not opening any account with some initial values, right? Suppose I will open an account 2, right? So, and let's display print account 2 dot balance. Right. And first of all, let's find these. Just copy paste. Okay. Account is not defined. See, it is the constructor is started, right? The constructor is directly asking me to enter the name. We are now inside the constructor, right? Now let me enter my name and then the account number. See, it is displaying the balance, the current balance, balance of account 2, balance of account 2, that is 0. Amount by default, if there is no value given to the amount, take the value 0. That is only default arguments, right? We have seen this one. Now, just let me know this statement, this constructor call, this object formation is also correct. We are providing an argument to the constructor. Here again, we are providing no argument to the constructor, but both are correct, right? Both are valid. That is only polymorphism means. Okay, here the account exists with the amount. Here the account does not exist with the amount. Existence of the same account, that is existence of the same method, same message, but in different forms. That is polymorphism. This account exists to take the amount, but this account is there is no need for the amount. But they are calling the same function. The same init method will be called again and again, right? So this constructor, this init method, right? Just let me hide all these. See, uh, this init, okay, this constructor is valid for this object formation and also valid for this object formation, right? So both for both object formations, the same constructor is valid. That is polymorphism. This constructor exists for this account also and this account also, right? I think now the polymorphism is clear. Okay, guys. So some doubts. Just comment on these. Okay. Now let's see a little bit of inheritance. Suppose there is a let's suppose there is a class and the name of this class is telephone, right? Telephone. There is this another class and the name of this class is mobile phone, right? So there are some basic similar features between them, right? this telephone this telephone is able to dial numbers, right? Make a call. Again, this mobile phone is able to make a call and dial numbers, but there are some extra features inside this mobile phone, right? That is, you can save images, click images, something like that. So let's see how inheritance works. Suppose we have a class that is phone only, right? And we are taking very basic example. So let's forget about the constructor. First, define make call self. Sorry. Okay, guys. I think just let's finish this one very quickly. Print making call, and there is someone that is mobile phone, right? And define make call, then take self and print making call. Okay, so suppose these are two different classes, right? But what is the benefit of using class and objects if you have to define the same features again and again? This feature is again making call. This feature is also again making call. So in inheritance, what happened? This is the syntax for inheritance. Just use the name of the class, right? And now, see, just use pass. I don't want to put any code inside this mobile, right? Now, I create one object that is mobile one. So this mobile only. Now I'm calling mobile one dot make call. See, this make call is not defined for this mobile, right? This make call is not defined for this mobile. This make call is defined for this phone. But the use case, the feature will be same, right? Both devices are going to just make a call. Let's see what output we will get. See, we get the output making call. So this is what inheritance means. Just there is a very, like, what you can say, basic example, like used again and again for inheritance. Suppose this one is your father, right? And you are going to inherit some properties from your father. This is what somewhat similar what is happening here. This is a property, this is a method inside this phone, and this phone is inherited by this mobile. Okay, and now mobile has access to use this function, right? If there are any attributes, like if there are any attributes, okay, iteration path, yeah, constructor acts as an iteration path. Yeah, you can construct loops inside constructor. Constructor is nothing more but a method only. Whatever you can do inside a method, you can do inside a constructor. Model 1 2 3, suppose. But the mobile has some other models, right? It has a model. Suppose a new model. Okay, right? Now what happened if you will print mobile one dot model? What it will print? See, we get making call. This making call is from phone. This method is inherited by mobile, but this model is of its own, right? So this is what inheritance. You have some of your own property. You have some of your own property. Suppose it is your own property, and your father have some property, but you are sharing it, right? You are inheriting that property, right? So this model will be not inherited because the class mobile has its own model, but this make call method will be inherited and can be used by this mobile class. Anything anything inside anything inside this class phone can be inherited by mobile and can be used, right? So guys, this is a very basic, I mean, the baseline of the inheritance. Okay, any doubts? There are there are total, I think, total type of inheritance, 5 types of inheritance, but Python doesn't support all 5 types. So if some back to pull that, yeah, 6%. Let's see. See, just uh, observe and listen to me. See, there are some things which is known as specialization and generalization. Suppose, right? Suppose this first class, it is a phone, okay, basic phone, wired phone used in 90s. Okay, what are the basic uses of this phone? That is, it makes calls. it dials a number. That's it. No more features, right? Suppose you you open a company, a new phone is launched in the market, and the new features inside that phone is that it can save a contact and it can click pictures, right? Now again, there is some new company who launch a new phone. It can record a voice. It allows you internet surfing, right? Then again, there is some other phone where suppose you have some new features like you can use AI like chat GPTs, and you can use new applications like WhatsApp and everything, like, right? So see, the just observe the pattern. Each and every phone should have each and every new model of the mobile should have the property of this phone, that is the basic property of the mobile, that is making calls and dialing numbers, right? So see, all of them are referring to the same class. This is known as generalization. Okay, the bottom up approach is known as generalization, right? Each and every different types of model or different types of company have the same feature, that is dialing a number, creating calls, right? Now again, what is a specialization? So see, see, for this new featured phone, there are two new features, right? So this phone is unique in itself, but it is also using the property of one, the above the phone class, right? So this one is known as a specialization, using your own property and inheriting some other property from above classes. That is specialization, right? So guys, this concept of generalization and specialization goes very deep, right? I think if you have heard about the what we call DBMS, database management systems softwares, there also this generalization and specialization is very what you call it crucial there. Right? So whatever we have seen till now, uh, just to give the notes. Yeah, whatever types of things we have seen till now, like those basic. Just take the list again. Okay, let's take the list again. Right. See, this list class is also inheriting some other class. Right. We have seen this tuple class is also inheriting some class, right? So this is only the way to what you call design an object oriented system, right? Inheritance, polymorphism, encapsulation, and abstraction. Those are the four pillars for in object oriented programming. Class and objects are only the way. Yeah, I will share the notes. Okay guys, just let me know if you have any doubts, or otherwise we will close the session. Pass keyword. Okay. So see, if I define a class, my class, okay, I am bound to write some codes inside it, right? If I don't write any codes inside it, see, I will get an error. See, I will get an error, right? But I don't need any. Suppose there is such requirement that I don't want to put any code inside that, right? I mean, middle of the development. Right now, I don't want any code inside that. For that, you just use the pass keyword. The pass means that just neglect this one. Just neglect this block of code. There is no code there, something like that. Okay. It is not similar to neglect, but pass means that just leave this block of code. There is nothing there. Okay. It just validate your empty block of code. Right. Okay. Uh, Thank you for the session, guys. And if you have any doubts, I think there are no more doubts. Okay, guys, let's close this one now.
Thank you, everyone, and of course, our mentor for this amazing and informative session. That was all for this 4-day live workshop. We will continue providing such courses and workshop in near future. Wishing for your love and support. Thank you very much.